Hi everyone, this is Mrs. Jackson. I'm putting together a very quick review of exponent power rules with a focus on negative exponents. As you already know, a power is just mathematician shorthand, so 5 to the 4th power means that you take that base 5 and multiply it by itself 4 times. So these are equivalent. An algebraic expression could look something like this. And in this case, we have x times x and y times y times y. All right, so quick, take a look at some products of powers with the same base. Keep an eye out for things that have the same base but might not look like it. So, for example, maybe 2 cubed times 4 squared. So in this case, we have 2 cubed, and 4 is actually 2 squared. So there's that same base. And so we've got 2 cubed times 2 squared times 2 squared. And you count how many you have here. So you've got 3 2's here, 2 more. Button it all together, and we've got 2 to the 7th power. And so the rule is if we have the same base, say m to the a power times m to the b power, you can see that we're just adding them, and you can see why. Because they're all multiplying each other out, and you're just counting them. So a quick little algebraic example, x cubed times y squared times x to the 4th times y. So we can count these all out. I've got 3 x's here, 4 here. That's going to be a total of 3 plus 4, which is 7. And I've got 2 y's here and 1 y here. So I've got y cubed. All right, let's take a look at quotients of powers. In other words, division. We'll look at a numerical example, say 4 to the 4th power divided by 4 to the 2nd power. What's happening here? We've got 4 4's up on the top, multiplying each other. We've got 2 4's on the bottom. Whoopsie, I wrote a 2 as I said the word 2. And so you could see pretty readily here that anything divided by itself reduces out to 1. So that pair is going to go away. And we have just 4 times 4 up at the top, or 4 squared. And so the rule is if we have some kind of base, I'll call it m, and that's raised to the a power over m, and that's raised to the b power, you can see that we're simply subtracting those exponents. 4 minus 2 will give you 2. And you can see why we're subtracting them, because they're just really reducing out to 1. All right, so the real focus of this video is to talk about negative exponents. So if we take a quotient example, kind of similar to what we did above, I'll just make a problem up here. 5 cubed over 5 to the 5th power. If we write that out, we have 3 5's on the top, and we have 5 5's on the bottom. And so just like the example above, we're going to get some pairs that reduce to 1. In this case, I've got 3 pairs. So what's left up here on the top is just the number 1. And so what I have left is 1 over 5 squared. And so if we use our rule here that we've done in the past, or we just reviewed up above, I should be able to subtract these exponents. So 5 is the base, common base. 3 minus 5 is negative 2. And we see that 5 to the negative 2 has nothing to do with negative numbers. It simply means take that base down to the denominator and keep the exponent as 2. So 5 raised to the power of negative 2 is 1 over 5 squared. Now what happens if you have a negative exponent already in the denominator? So let me try another example here. If I had, say, 4 over 4 to the negative 3. If I wrote that out, I have 4 on the top, and that negative exponent on the bottom says, bring that down to a denominator and keep that exponent. As you know, if we're dividing by a fraction, that means multiplication of the reciprocal. So that 4 cubed really goes up on top. So we have 4 times 4 cubed, or 4 to the 4th power. So in other words, that negative here just says, bring this 4 to the 3rd power up to the top. All right, let's just bring all of this negative exponent rules and quotient rules together so that we can simplify a rather complex expression. So I'm just going to make up an expression real time here. So if I had x cubed y times w to the negative 3rd, and below I had x squared times y to the negative 2 times w to the 4th. Let's take a look at what's happening here. We'll take it one step at a time. So first I have, let me circle this in color. I have the same base here. I have 3 x's on top, 1 on the bottom. The rule says subtract those exponents. And so what do I have left? I have x to the 1 power, or just x. Next, I'm going to take the y's, and I have 1 y up on the top, and y to the negative 2 in the denominator. That negative 2 exponent is saying bring these 2 y's up to the top. Since it's already in the denominator, we're going to move it up to the top. And we already have 1 up there. So we have y already, and we're going to bring up y squared. And then if we look at the w's, I've got a w on the numerator with a negative 3. That's saying bring those to the denominator. And so what do I have here? I have quotient. I'm going to bring 3 w's down, and I already had 4 down here. All right, so I am going to go ahead and just simplify whatever I can. Up on top, I have x, I have 3 y's, and on the bottom, I have 3 w's times 4 more, or in other words, w to the 7th. And that would be our final simplified expression. Anyway, the focus of this was just a very quick review of exponent rules with an emphasis on negative exponents. Thanks for listening. Hope it helps.